Hello again, students. In this video clip, I want to talk about the way in which we get information systems in-house, wherever. It's called developing information systems. Strangely enough, it's a process called systems analysis and design. Sometimes you'll hear people say process analysis and systems design. Doesn't matter what you call it. The whole concept is that information systems don't just magically appear, they have to be somehow developed. And so this is the process that is generally used when we go about developing information systems, okay? So in the first few slides, I give you just simply a little review of processes. But the next thing, first thing that's different, it talks about the information systems life cycle. Now, the life cycle simply implies that information systems do not last forever. They don't. Information systems have a life expectancy. And what you would hope is that that life expectancy is significantly long enough to make sure that the information systems we have and have in place are information systems that are going to last for a reasonable period of time. But over time, information systems decline in usefulness, and this is something we all know. And so what we have to do when they start to decline in usefulness is to somehow renew them, rejuvenate them, replace them if necessary. Hopefully you don't have to do this always, but you have to understand that over time, the systems get old, the technology gets old, the software and the hardware get ancient. Not as fast as maybe we need today. Information needs change. So there's lots of reasons why information systems sometimes have to be replaced or rejuvenated or whatever we can do to renew them, make them better. So one of the slides that I've given toward the front of this presentation talks about the amount of resources necessary in terms of getting the system up and running and then making sure that over a period of time, the system is useful. Once we determine that the system is no longer as efficient as it was when it was new, it's starting not to do what we need, then we need to go about the process of replacing. And this is a process that we call the Sdlc, the Systems Development Life Cycle. What the Systems Development Life Cycle is all about is a series of processes that you go through. And as you go through these processes, you start to understand exactly where the old system was not working properly and what we need to have for the new system or the improved system to replace the old system as it was working. So the stages that we go through, and this is typical for the Sdlc, we have a planning stage, we have an analysis stage, a design stage, a development, testing, implementing, and maintenance stage. So those are the stages that we'll talk about. It goes from basically looking at the system from a whole and then making sure that everything that we've done within the system is meeting the new system's needs, and we have a better system in place after the process. Now, I have a couple of slides that show you what the systems development life cycle basically looks like. My favorite is the one that has the straight line under it, and then it goes into a bit of a loop. And that loop is where the process would take place. And the reason I like this, it shows that we have an existing system. It's coming along. And as long as we can keep maintenance of that system and keeping the system working reasonably well, we'll keep the existing system in place. But when that existing system, which we sometimes refer to as a legacy system, when it starts to degrade, at that point, we enter then this loop that becomes the systems analysis and design phase, where we recognize we have problems. We decide they're significant enough to do something about them. We set about planning the project that we're going to do to replace that. We do an analysis. We design a new system. We create the new system, implement the new system, And then the new system becomes our existing information system. That's really the steps. Irrespective of how you go about doing this process, whether you're using RAD tools, rapid application development, or some other tools, it doesn't matter. The process is still pretty much the same. Now, the idea here is we got a system that's not meeting our needs. We need to do something that's going to make that system work and work better. And we want to do it in a manner that's going to be cost effective and time effective. So this is it. I have a slide that talks about what makes a system not so good, bad system. Bad systems are those that aren't meeting our current information needs, don't work quite as like they ought to. They may have slowed way down. They may be poor performance. Systems tend to start to degrade and slow down. It's rather interesting, kind of like us old people. We start to slow down when we get up into our 60s and 70s. And so we don't have quite the vigor that we had when we were younger. Same thing's true with an information system, folks. So if we see any of these problems cropping up, then we typically will have somebody in the business who's saying, look, it's not working for me. So what they need to do, this individual says, hey, we got problems. They go to their boss, their manager. If they're not a manager, they may be a manager and recognize that they have issues. They go to their boss and they say, look, we have to do something about this system. They then would write up a request that would go to a board. Typically, we call this the review board or the systems overseers. They will look at it. If they say, yep, looks good, they'll initiate the project. And so the planning stage has basically 4 or 5 different steps that we go through, okay? Somebody's identified a problem. They write up a request. They give it to this panel. This panel then looks at it and says, looks reasonable. Then they give it to a systems analyst, a specialized person who is going to be the person who's going to oversee the project. They'll do a feasibility study, look at if it looks like it's feasible, then it'll go. So this person that's going to be the recognized oftentimes becomes the sponsor of the project, the champion of the project, if you will. The person who's going to make sure they recognize that there's a problem and they say, look, we have to do something about it. They take this request to the steering committee, the IS steering committee, this group of people that look at proposals, because you can't do everything, obviously. But they'll look at this and they think if it's a significant enough problem, if there's a chance that it might do something, we need to look at it closer. They give it to this systems analyst. A systems analyst, a person trained who understands business, a person who understands information systems, a person who understands technology. So they have to be a broad-based person, generally with a lot of experience. And then these people will do a feasibility study. And basically a feasibility study is exactly what it sounds like. Is it worth doing this project? And we basically ask 3 questions. Can we do this? Is it worth doing? And is it going to benefit the organization? So we have these 3 types of feasibility that the business analyst will do. First is technical feasible. Can it be done? Are the technologies available to do what needs to be done according to what this problem or how to meet the needs of this problem? If it's technically feasible, then you look at organizational feasibility. How's it going to fit in? In other words, the analyst isn't just going to make a decision. They're going to talk to people. Stakeholders are people who are going to be impacted by this change in the system. They'll talk to people. Will this benefit? Seems like it would. Yes. They'll go. Then it becomes feasible for the organization. You also will do an economic feasibility. An economic feasibility basically is where you do a cost-benefit analysis. How much does this business analyst expect this system to cost initially? And what's the estimated benefit from it? So if it looks like we're going to get about $100,000 worth of good, and it's going to cost $200,000 to do it, doesn't seem very economically feasible. However, we're going to get $200,000 worth of benefit for a $50,000 investment. That seems more reasonable. So an economic feasibility simply is an estimate of how much this process or this change is going to cost us and what kind of benefits we anticipate about getting. So we'll start to look at this situation, try to determine how this is going to impact the business. The systems analyst will then write up a report, give this report to this committee, this steering committee, these IS people that look at the process problem. They aren't just IS people, by the way. They're people within the business that understand systems and systems processes. They can be in marketing, be in all kinds of areas, and probably should represent a cross function of the business. Anyway, this steering committee is going to look at this report, and if the report from the business analyst looks good, they'll say, okay, create a work plan. And a work plan is exactly what it sounds like. It's a document, a written document that estimates what the costs are. We're going to be talking about project management in another video clip that I'm going to make. Basically, it's the start of a project. And the work plan simply identifies what is going to be part of the project, what the project's going to be. So you're going to have a description of what the project is and the expected outcome, what kind of issues are going to be involved. You're going to have the resources necessary, how much time it's going to take. A lot of information is in this work plan. This is then given back to the steering committee, and the steering committee looks at it and says, looks like it's good to go. Create a work team. So they create a project team. A project team are people that have a number of skill sets. These are people such as systems specialists. There'll be design specialists, programmers, technical people, as well as people from the user group. Now, this is the first of many times you're going to hear me talk about the user group and the importance of the user in this process. Because if you get nothing else out of this video clip, I want you to understand, you will probably, sometime in your work life, be involved in a project similar to this. And user involvement is absolutely essential if the project is to succeed, period. Okay? So we need user involvement. The steering committee will look at this and say, sounds good. Sounds like it's worth pursuing. Ignore the phone. So, what then we'll do next is enter the analysis phase. The analysis phase is very simple, but it's also a lot of fun. It's probably the most enjoyable part of all information systems works from my perspective, because this is where the team becomes detectives. The team looks at every aspect of the business that involves this system, this information system. And they ask the 5 W's and the H. When, where, who, what, why, and how. In other words, they just dig in and start studying the system. This is where critical thinking is absolutely essential, because critical thinking allows the people to determine, the team, to determine exactly what is the issue, what is the root cause of problems, how is the new system going to improve this. It's absolutely imperative that the analysis does everything necessary so that we can get to the bottom of the issue, the problem of the issue, and start looking about how can I resolve this issue and make a new system that is going to take care of our problems. So, how do you do this? Well, you talk to people, you look at documents. I've got some listing in terms of just looking at information requirements. Information requirements assessments critically important, because if we don't, and every business should do this, by the way, if we don't occasionally do an information needs assessment, we never know exactly what information is necessary. And who knows what information is necessary? Certainly not the IS guy or the IT guy. It's the user. And so it's imperative that the users are actively involved in this whole process, because these are the people that will tell the analyst and tell the team what needs to be done, why it needs to be done, where does it have to happen, who has to do it. These are questions that we absolutely have to have answers to if we're going to create a new system that's useful. So we do this in-depth, we hope in-depth analysis of the current situation and what the new situation ought to become. And then we create what is called a requirements analysis. We have then, we know what benefit, what the old system wasn't doing. We know what benefits we can get from the new system. And we can start preparing a systems proposal. Okay? So how do you do this? Well, you build models. Remember Visio? What was the purpose of Visio? To build models of processes. This is exactly what you do. You get all this information, you build these models, you do all the requirements analysis you can, then you build models that are going to show how the system was, and this is what the new system ought to be. You present this to the user group. The user group says yes or no. If they say yes, well, then you're on the right track. If they say no, you go back and do a little bit more analysis, do a little more digging, because you haven't got everything yet. But once the users say, yeah, it looks like you're on top of what's going on here, then you can build a systems proposal. And a systems proposal basically is simply this. It's a document that is to be given to the steering committee. And this document has all the information that we have determined in the analysis phase, with diagrams, flow diagrams, data models, everything's necessary. And we present this proposal to the steering committee, to this group of people, this committee that's going to oversee this process of managers. Well, we give this to them and they look at it. And when they look at this, they're looking at it with critical eyes. We have some suggestions on what we think ought to happen. And so the steering committee has one of three choices. They can either say, well, you did an okay job, but we don't think this proposal's worth it. They can pull the plug, just stop the whole process at that point. We hope that doesn't happen, but it has happened. Or they can say, this looks like something, but what about this, this, and this? Which means that you go back and you do more analysis, working on the proposal again. Or finally, they can, and we hope this happens maybe, doesn't always happen the first go around, understand that the board will say, okay, let's proceed. Now, the next phase is called the systems design phase. And the systems design phase, if the analysis has been done well, the systems design phase shouldn't be too terribly difficult, because you can take the proposal, and what you do at that point is just simply take it, create the logical design of the system. This is what the system will look like as you visualize it mentally. Then once you have that done, then you can create a physical design of the new system. What the hardware needs to look like, what software is necessary to run this hardware. And during this point in time, the end users are the people that are absolutely essential, because they're the people that are going to drive the design of the new system. If the user group does not have input here, you're just simply asking for trouble. I can say that from experience. Once upon a time, I got called into a systems project right in the middle of it. Because what had happened is that an IT group and a couple of managers of this, I won't tell you what group it was, but let's just say it was, it was interesting. Let's just put it that way. Anyway, what had happened, the IT group and the managers, some of the managers, not all of them, but some of the managers in this particular group did not have a fully representative steering committee. They just had a few people that said, we got to have this new system. And so these managers took over. Well, they decided with the IT people what the system ought to be. And somehow the user group got wind of what was going on. And they were able to see exactly what this new system was going to look like. And they hated it. They absolutely hated it and basically had a minor revolt. And top manager was smart enough to figure it out. We have to do something, because if we do what the current system proposal is, we're going to have trouble. And so they called in an independent consultant. And I went with the user group. We worked with the user group. We worked with the IT group, and we got a compromise. Came up with a new system that had a better interface and a system that the users were happy with finally. And so they settled the differences. Now, had they done this properly in the first place, they never would have needed any outside help from me. They got some. It evidently seemingly worked. But the point is, the users have to be actively involved, not only in the analysis phase, but in the design phase. Very, very important, because the design phase is, how is this system going to look? How is this system going to work? What are the interfaces the users are going to have with the system? If the users aren't involved in this, folks, it's a disaster. Let's just put it that way. So the design phase just basically looks at all the different kinds of specifications necessary to make this new system work. Okay? It covers everything from A to Z. You go through the whole process, make sure that everybody knows what's supposed to happen. You talk about how we're going to take the old system, go from the legacy system, the old system, into the new system that we're developing, how we're going to convert all the data files, how we're going to do everything to make the new system work better. Okay? It's all spelled out. You're going to talk about how we're going to train people, how we're going to make sure that everybody, before the new system comes in, before it starts, everybody will know what needs to be done, and how's this going to impact the organization, and who has to do what to make sure that this new system is going to bring in and come in and work properly. Okay. At the same time, then you are starting to create this basis for which software can be found or developed, depending upon how you're going to bring in the new system, as well as documenting what the new system will be, because this is absolutely essential if we're going to make sure that people know how to use this system. So the systems development phase then is simply taking the design and putting basically meat on the bones. The design is the skeleton. The implementation is getting the right hardware, making sure the networks are set up, making sure the databases are set, making sure all the software that's necessary to drive the system, if it's an ERP system, make sure we have all the modules we need. It's just all the things that we've looked at, how it's put together. So this is done by the project team, the IS team, the team of professionals who are going to oversee the process. They'll be working with the programmers if we're writing it from scratch. They'll be working with the vendors if we're going to buy the system. We have options here. But once the system is developed, once it's in place, then we test the system. And the testing simply is this: running through the system with various scenarios to make sure that the system in all ways and shapes is doing what the system was designed to do, what it's supposed to do. So once we have that, once we test out the new system, then we make sure that everything and everybody understands exactly what they're supposed to do, when they're supposed to do it. So the end users have been involved all the way through this part. And why do I keep stressing the end users? Because that's you. Unless you guys are going to be IS developers and IS professionals, you're going to be the end user. So this is important for you. You got to understand this is important for you because you have to be right on top of the system at the point in which the system is implemented into the process. So you need to make sure you're sufficient training, that people know exactly what needs to be done. Make sure the whole process is pretty much done, so that after we have converted to the new system, everybody will be on board. They'll know exactly what has to happen. Now, once the system's developed and once it's tested, then you go through the conversion stage. The conversion stage is interesting. You have several options. You can do probably the safest if you have a system that absolutely has to work, a fail-safe system. Probably the safest way of converting is parallel. Parallel system conversion is simply this: you have the old system that's working, and you've developed the new system. So you got the old system up here working, and now you have the new system. And you put it into place, and it starts to work, and you run the two systems together for a while. And once you determine that the new system is working and working satisfactory, then you cut out the old system, and the new system becomes the information system. Now, this is safe because you always have backup on this. The problem is you're running two systems, and it can be fairly costly to run two systems simultaneously, but it's safe. That's the key. You have the other extreme, which is called the direct cutover. This is one where prayer is helpful, because what happens is you have the old system running, and then on D-Day, you cut it off, and the new system starts. It's by far the most cost-effective way of doing it, if there are no major bugs in the new system. Notice I said major bugs. There'll always be bugs in the system. You're always going to have issues with a new information system. That's just part of it. But if there are major bugs and you have done a direct conversion, wow, you can have trouble with the new system. So while it's very cost effective, it's also risky. Now, the other two methods are sort of a hybrid with those two. One is called the pilot. The pilot is where you go to a place in your business where the information system might not be as mission critical as it might be in other places, and you put the new system in place there and have them work with it. What they do is they work with the system. If it's working fine, then introduce the new system to the entire business. Doesn't always work for all kinds of businesses. They might not be able to do this kind of thing. The other method is called the phased method. And this is where you introduce a bit of the new system, replacing a bit of the old system. For ERP systems, this works fine because ERP systems typically are modular. Ball State, a number of years ago, went to an ERP system. And the way we got into the ERP system was it was phased in. The first module we introduced was the accounting and finance module. Okay, so we took the old accounting finance part of the system up, put in this new system, this new ERP module, got it working. Then we put in the student module. Then we put in some other administrative areas like HR and some of the other modules that were then introduced. So it was done over a period of time. This is a fairly safe way of bringing in and converting into a new system, okay? But you have these options. Again, the safest is parallel. The most dangerous is the direct conversion. And the other two, the phased in or the pilot, are somewhere in the middle of that, okay? So once we have this new system up and running, we go into where we want to be, and that's the production phase. We hope the production phase, we go back to some of the earlier charts that I gave you, the production phase is a long period of time where the system is usable. We can, as long as we keep good maintenance on the system, as long as we keep it up running reasonably well. If we have problems, fix the problems, make sure that keep the system going. If we can get 6-10 years out of this system, great. We're going to have some major revisions. Be a replacement of hardware possibly. But keep in mind, someday the old system will get tired and we'll have to go through this process again. Okay? Now, is this a perfect system? No, there's some criticism. I've listed some criticisms that people have. One of the things that we look at the Sdlc is that it takes time. This is probably the biggest problem. It is a time-consuming process. And some people have criticized it for being very, very slow. Okay. In theory, you can go from place to place. For instance, if we get in the development phase and we discover something's wrong, in theory, we can go back and even go to the analysis phase again. Some people say that's not realistic. My experience with the Sdlc is that it does work if you do things carefully, and that's really the bottom line. But some people say, oh, it doesn't involve the user. It doesn't have to. That's how the projects run. If the project manager wants to involve the users, they'll be involved. So make sure that if you see something being changed in a business you're in as a user, make sure you have some involvement, or at least somebody representing your group, because otherwise it's going to be problematic. Okay? Now, some of the major complaints about the Sdlc is the fact that it's time consuming. So there are things that we've done. Rapid application development. RAD, your book talks about some of these things where we have all these various kinds of tools. For instance, you saw one tool that we use, and that's Visio. What is Visio? Visio is a computer-assisted design tool, a CAD tool. We have object-oriented programming. We have lots of new techniques that we can use the technology to expedite the system production, the development of the system, as well as the design and the analysis of the system. We can use some of these tools to speed things up, and that's good. I have a little slide that talks about case tools, computer-assisted software engineering, how it can speed up the development of the software. So we have different ways of going about doing this. I have a slide in here that talks about the different kinds of approaches that we can have in terms of expedition. We can do what's called the Sdlc, the strike, which I just talked about. We have this thing called ad hoc programming, also called prototyping. Prototyping is very useful if you've got a small system. Basically how prototyping works, pretty simple, is you have somebody who is an expert with software engineering tools, case tools. They can then take these tools and sit down with the user. And the user tell them what kind of system they think they need. The prototyper, the programmer analyst, will then sit down with these case tools and generate a system. Now, this doesn't work with real large scale things. You have to go pretty much to the Sdlc for that. But if it's a small informational need, they can gen up a system. And they can give the system to the user and say, here, try it out. And the user can take the system that's quickly generated, a week or two, use it, sit down then with the prototyper and say, hey, this worked, but this didn't work. I like this. I hated this. The prototyper will take that, the original model, create a new model, give it to the user and say, use this for a while. Well, you can do this 2 or 3 iterations, and after a while, you're going to have a system that'll be pretty functional. The advantage here is speed. The disadvantage is never going to be 100% complete, plus the fact that if the prototyper leaves, it probably hasn't done any type of documentation. So if they leave, you might just have this orphaned system out here, which you never want, an orphaned system. RAD tools, your book talks a lot about RAD tools, so I'm not going to take the time to talk about that. But this other thing called end user development. Now, you might be thinking to yourself, I'm not a programmer, I'm not an analyst, I can't develop systems. Oh, yes, you can. Because everybody out there has been a programmer at one time or another. You all have, because you've developed spreadsheets. And a spreadsheet is nothing more than programming a computer, because you're simply telling the computer what you want it to do. And there have been instances in businesses where people have taken tools like Excel, Access, and other tools that are available to the end user and have actually developed their own little system that have proven to be very useful. That's actually how the original spreadsheet started. This fellow wrote this spreadsheet, was using it for class. A bunch of his buddies wanted it. He gave them to his buddies. And after a while, his buddies wanted it, and his buddies wanted it. And he thought, why am I giving all this away? He started selling it, and that's basically how VisiCalc, which was the first spreadsheet, started. So end user development's a reality. You can actually do that. Okay. So we have these fast ways of developing things, and like I said, I'm not going to spend much time talking about it, but I do want to talk a little bit about some of the reasons that systems have failed. And I've included some slides in here that talk about that. And it's simply because we have taken shortcuts where we shouldn't have. That's the biggest problem. And you can read through this list of causes and symptoms of systems failure because we haven't tested, because we've overlooked things during implementation. There's lots of different reasons why the system won't perform as it should. Now, these slides are primarily for IS people, but I want you to look through them. I want you to look and see the numerous types of issues we can have in systems development. In order for a system to be proper, work properly, everybody has to be involved. And I cannot express that enough. Okay? The last thing I have about systems development is how we go about obtaining systems. Now, the way I just talked about it assumes that we're going to do the in-house development, which may or may not be the case. We have other options. Now, after we've gone through the analysis phase and part of the design phase, and through the design phase probably, we then have this option. Are we going to build this system in our business, or are we going to go outside to get the system developed? Most small businesses or medium-sized businesses probably will not do in-house development. More and more people are not doing a whole lot of in-house development, but they go to software developers who will then provide the systems that will have the software and the hardware that is necessary to implement the new system. Okay? The problem with in-house development is that you have to have software developers, you have to have IT guys out the wazoo. It's expensive. Good IT people make good money. For instance, a good programmer is going to make $80,000, $85,000, depending upon where in the country. I'm talking about people around here. They're going to make that kind of money. A network administrator, close to $100,000. Database administrators, close to $100,000. These people are expensive. You got it, and you're going to have some IT people in your business. But A small business or a medium-sized business probably will not want to keep a complete development staff. And so what they can do is either outsource the project or acquire or purchase an existing system. Those are your other two options besides in-house development. Outsourcing basically is I'm going to a systems developer. I'm going to take my specs, the analysis and the design, the specifications of what this system needs to be, and I will give this to a vendor who will then take that and create it. That's outsourcing. Or I can go to a vendor who writes software in the business in which I am. If you're in transportation, there will be lots of various software vendors that have written and support software that will be able to accommodate your business. Now, the beauty of outsourcing is the system will be developed to your specifications. Now, it's costly, but it's not as expensive as maintaining an in-house staff. If you acquire a system, what you get is immediacy, which is good sometimes, a system that will be proven. You won't have to debug it, as you might have to with outsourcing. Actually, the outsourcer would be the one that would be responsible if you write your contract properly. But anyway, when you acquire a system, you basically are getting a system that everybody can have, including your competition. So you may not get a competitive advantage necessarily like you might if you outsourced or if you did in-house development. But the advantage of acquisition of a system is the fact that it's quick and you be reasonably sure that system is not going to have a lot of bugs in it when you start. So there are trade-offs you have to make. But regardless of how you go about doing this, if you decide to purchase the system rather than build it in-house, there are some steps you have to go through. First is finding a vendor. So how do you do that? Well, you generally will put out what is called an RFI. An RFI is a request for information. A request for information where you send this to various vendors. For instance, if you're acquiring a system, you'd send this to a bunch of vendors saying, do you maintain these kinds of systems? If you're going to outsource, you would send this RFI to the potential people who could build the system for you, who have the skilled employees that can build systems for people, and say, could you build this kind of system? Now, if they respond in a positive manner, then you would either issue an RFQ, or if you're looking to finalize it, an RFP. An RFQ is a request for quotation where you can get a ballpark figure from the vendors about how much they think it would cost for this system. An RFP, request for proposal, is where you're asking for a formal proposal from the vendor who will then negotiate with you the pricing and what all needs to be done in the system. An RFP is a very formal document. I have a description of what an RFP basically is. An RFP is this document that the vendors look at. You will send out a proposal, and a proposal for a comprehensive system can be several hundreds of pages of documentation, because what you are giving them is this document that specifies your exact information needs, what you want, and the kinds of information you need to get out of the system. You're going to be, if you're issuing an RFP, you're going to be giving a lot of sensitive information to the vendor. And in turn, the vendor is going to be giving you a lot of sensitive information about their business, because they're going to be telling you exactly the kinds of things they can and cannot do, and they probably don't want their competition to know that any more than you want your competition to know what's involved with your business. So it's very standard practice that if you issue an RFP, that both parties will sign this letter of non-disclosure. And basically what a letter of non-disclosure is, it's called a non-disclosure agreement in NDA. This letter of non-disclosure simply is a promise, a legal binding promise that you will not disclose any information about their business to any of their competition, and they will in turn sign an NDA with you saying they won't disclose anything about your business. This is very important. Keep that in mind. Okay? So once you have gone through and you get these proposals back, you'll generally get 2 or 3 proposals so you can have a basis of comparison. The team will then evaluate them. This is the analysis design team, will then evaluate the proposals and select the vendor they think would do the best job for the business. At that point, the proposal from the vendor is the basis for which you can negotiate a contract for the new system. And once you've determined what the new system ought to look like, then you go through the process of implementation and the conversion, everything else. Keep in mind, a good RFP and a good contract will spell out every detail of the system, how it's supposed to work, who's responsible for what, who's responsible for the training, who's responsible for the data conversion. All of these things are absolutely essential if you're going to have success in terms of getting in a new system. It can be a lot of fun. It can be a lot of heartache. I've never seen one that's worked 100% the first time. But after the bugs are worked out, almost always, if the users have been involved, people are happy with the new systems.